So, hello everyone, and welcome to this stream. So today I'm live with Ankit, and we'll be learning about SigNoz, observability, and monitoring the applications, and a lot more. Very excited for this one, and because it's been a while that we haven't touched the observability domain, and I see a lot of folks are super excited. Hi Ankit, and hi Rahul. Hi, Saloni. Hi, Nikhil. So glad to have all of you on the stream, and we're super excited for this one on SigNoz, a new open source tool which powers observability of the applications. And we learn a lot about this today. And I'm joined by Ankit today, who is passionate about technology, passionate about observability domain specifically, and who is the creator of SigNoz and maintainer managing the project. And obviously, he's also looking for a lot of contributions from the community, so which we'll talk about in the end. So stay tuned till the end, where we talk about how you as a community can contribute towards the project, and also how we'll use it. We'll be having a demo. We'll see what observability is. We'll see what SigNoz is, why SigNoz was created in first place. So I'm really excited for this. So Ankit, welcome to the stream. Would you like to introduce and say hi to the friends?
Sure, Shayam. Hello, folks. How are you? Hope everyone is all right, doing all right during this tough time. Thank you for
Yeah.
taking out time, and specifically Sayam for giving me the chance to talk about SigNoz and the keyword observability here. Would love to talk more how we came to the solution, what is the problem that we were dealing, and what has been our journey through it. So that's pretty interesting. So as my background, so I am 14 grad from IIT Delhi. Then I worked in Citibank. Post that, I started a couple of my own startups earlier. They were in image processing, machine learning domain, and retail tech domain. Post that, I was AVP engineering in a startup in Bangalore. I handled a team of 8 to 10 developers. We had completely into microservices architecture. So I understood the pain of debugging microservices then and there, right? So each one of there were 4 or 5 teams and 8 to 10 microservices, and people were shouting on one another like your services is breaking, your services are breaking. It was actually difficult to log into servers and find out the root cause of things right there. Cool. So my journey began there. It was then that I was introduced into this domain of observability. I actually got to learn about that word after that. So it was just 2 years back, right? So it has been a fascinating journey from me to discover these domains and how things work and how do we take care of monitoring, tracing, and logging solutions. So after that, I quit my job. I started to look into most solutions that can help people out to uh, debug their applications in production, like monitor them, like how is their application basically performing in the production, right? And with today's world of microservices, it became more and more important to do it. I'll discuss with you in detail in the slides. So let me start by sharing a slide of my own, and we can discuss more around that.
Yep, sure. And so those of you who are new to the channel, do not forget to subscribe and share it with your friends. In the meanwhile, Ankit is sharing the screen. Okay, I think we can see the screen. Yes. So Ankit, let's begin it. I'm super excited for that.
Cool. So we are building a full stack observability platform. So observability means you should be able to look into the systems that are running, given a set of outputs that you can observe. Like, so observe is the keyword here. Like, given the set of outputs that you're seeing, you should be able to know how your systems actually are. Like, if a person is looking happy, that is the output. You should be able to understand what is the thing that is behind that happiness, whether he got a salary hike, whether he got a child, or he is promoted somewhere in some other way. So that's the kind of reasoning. So it can be a bad analogy though, but that's the genesis of this word. Like you should be able to observe things, right? And what the words are very important here. Like full stack is we came to the word full stack by using different OSS tools today. So there's been a different set of tools for monitoring, tracing, and logging. So combining those has been a bit of pain for us. We'll discuss that also later. So we wanted to build a single platform. Platform is basically an enabler that can serve as a complete stack for complete observability. No other tools needed, period. So with that concept in our mind, we started building SigNoz. So let me give you a brief at what SigNoz currently is. So we want SigNoz to be a single pane of glass for metrics and traces for now. It will include loggings very soon. With the traces, we should have the capabilities to aggregate those traces. Like I would say, if in your code you have attributed a key value pair, like some annotation like a customer type is equal to gold, or a payment channel is equal to Paytm, you should be able to monitor those attributes specifically. But you should, as a business owner, you should be able to understand how much errors is my gold customer or the platinum customers facing, right? So those becomes very important from a business perspective. And we wanted to be out of box solutions, right? So we have seen the use cases of SaaS solutions like Datadog, New Relic, and the other open source tools like Prometheus and Jaeger. Setting up open source tools for to handle scale and for the scale of an enterprise is usually very much difficult and takes around a month or two to set those things up. So we wanted to bridge this gap with that. SaaS is an out of box solution, but very costly, and it is out of network boundary, and open source tools that requires a lot of efforts and time from the developers. So we want to bridge this gap. So we want to be an open source tool that requires minimum development efforts. And we want it to be a platform which is very much scalable. Like it should be horizontally scalable, and it should be able to handle the scale of an enterprise, like 1,000,000 events per second, right? And another curious use case for us is that for those industries like healthcare and fintech, where you are not allowed to send data out of your infrastructure boundary, these open source tools running within your infrastructure and within your network boundary is very important for your case. So you cannot send your personal identifier information and other data that can be audited over the network boundary, right? So with these, we started building SigNoz, and we know from the past that observability consists of three pillars like metrics, traces, and logs. So we are very much familiar with logs. We have been using that for a while, even for debugging small things in our development lifecycle. Like metrics is how average things are performing in your application. Like even if you are counting the number of steps that you're taking in a day, it's a metric, right? Any aggregatable data is a metric. And Prometheus is a fantastic tool that does that. So Prometheus can scrape data regularly from fixed targets at fixed intervals, and you can it can store on a local disk for some time, and you can display it on a beautiful graphs charts like using Grafana. And logs we have been using for a long time, and Elastic has been a big player in that industry. This is also open sourced, and Loki is trying to open up a space in structured logs and plugging in Grafana, and it gives you basically structuring your logs gives you the edge of being storage efficient. Like you should be able to index by keys, and the searching becomes very fast, and hence the storing is very much efficient. Now, tracing in the past few years, like around 5 to 6 years, it has become very popular with the advent of microservices architecture and Kubernetes. So the reason of going through that transition will be discussed soon. Jaeger is a very famous tool in that space that Uber has open sourced, which can ingest a lot of spans or events. So span is the minimum individual unit of tracing data that we usually have. So we can correlate spans with events. So these can be used interchangeably. And we can visualize the traces. And traces is basically bundling of requests based on a trace ID. Like I'll discuss in more detail in the coming slides, right? So these are the famous tools, Prometheus, Jaeger, and Elastic, and Loki, that can constitute your observability stack. Now today, as I discussed, is an era of distributed tracing. Why distributed tracing became very important is because of the microservices architecture. You switch from monolithic to microservices to improve the agility of the team and to increase the scalability of your systems or individual components. Like a monolith can have different parts, like a query part, a collector part, and an ingestion part, a query part, and a storage part, right? So when you abstract out each of these works or workloads into different services, you can scale them independently. Like if you have high ingestion rate, you do not need to change all the monolith or all the combinations of these services. Rather, you just scale up or increase the number of instances of that ingestion service. And similar for query, if you have a large number of concurrent queryable users, you would like to scale up the query service layer, right? So this is a sample, like a diagram from Uber, where a request goes through multiple, I would say, hundreds and thousands of services before responding back to user. The request comes to service A, so service A calls service B calls service C calls database, and it gives back a response to service D, and it propagates back the same way to service A and to the user. So it becomes very complex to debug now. So the request went from service A to service B. Now you have to figure out what went down. If something is going wrong, you have to figure out where actually it turned bad, right? Whether the upstream services are at fault, or the downstream services are down. Which instances of those applications or those services are down? Which deployment version are we talking about, right? So with microservices, we made the system more horizontally scalable, and the more the number of instances of different services running, more the relationship graph became prominent, and it became difficult to find out the root cause of things, which node or which event in the complete relationship graph is breaking. So that's why we tried using Jaeger. And with Jaeger, it's a simple tool with a simple UI that you can search the list of traces that match a specific criteria. Like this is a service name, this is the operation name, and this is the duration of the minimum duration of the events that you want to see. It will give you a list of responses, and you can see a complete trace in the Jaeger UI. By trace, again, I mean it's a logical grouping of the set of events that can be associated to one single request. Like single request can move from service A. Service A might have emitted 5 events. So it moved then to service B. Service B then emitted 10 events. Then service C emitted 30 events. Then in combination of the 50 events is basically one trace which corresponds to one request that came in. Right? So when we worked with Jaeger, we found a few restraints or restrictions in working with the UI. So the UI was basically minimalistic. So everybody wants to work with a perfect, I would say, scalable and beautiful backend, but very few of them want to invest time in the front end or the user experience sort of things for an open source projects. Obviously, they are bound by the time they can allocate to the building and improving of open source projects, and unless it is backed by a big company that is going to run that project continuously. Apart from that, as I told you, there is a need to run aggregates on the basis of annotated data or tags like customer type and payment channel. So these type of capabilities is not present in Jaeger. Like you cannot run aggregates on a set of filters applied on the spans or events. In Jaeger, you cannot even see the spans. So if you apply a few of the filters, you will be presented with the set of complete trace, which has a list of hundreds of events. Right. So that becomes the difficulty if you want to boil down to a specific span. So you have to go to the next page of the complete list of trace to figure out which span are we actually talking about. And similarly, since we cannot run aggregates on traces, there's no possibility of alerts. Like you cannot run an alert. Like alert is like something is happening for the last 3 minutes, 4 minutes, or 5 minutes, then send me that data. That kind of thing is not there in Jaeger, and which I feel is very important today. Jaeger even missed the criteria of multi-tenancy that is important for an organization, and the RPEX policies that should be there to control the data access layers between the data that we have stored in the Jaeger backend. Right, so that we lost a lot of information on distributed tracing data that is still not harnessed. Right. So I wrote a blog on running Jaeger with Cassandra, and you can go and look into it. I will post the slides later in the wherever channel that Shyam prefers. We'll post it on YouTube even, and we can discuss more on that. So what we did is we tried running metrics and traces using the existing open source tools like Prometheus and Jaeger. Right. So the problem with this backend is it became very much complex to manage both metrics and traces. So what we did is, this is a sample virtual machine that is there. These are the machines and nodes. We send the data from each of the application. We send data. We have a client library that is included in that application, which sends data to OpenTelemetry collector. So likewise, we have 3, 4, or more applications running in a machine, which sends data to OpenTelemetry collector, and likewise many machines are there, and the hotel collector sends data to the API gateway that is there, that we built specifically earlier to facilitate the authentication process and the multi-tenancy part. And we used to run Jaeger collector and Prometheus server as a single tenant solutions for each and every tenant. Like we used to have this pair that Prometheus used to receive metrics and Jaeger used to receive traces. And similarly for each tenant ID, we used to run this service. And both of these used to write to Kafka to handle the scale of data that we are receiving. Now the metrics and traces pipeline became separate. So they were already separate in Prometheus and Jaeger collector. So it remained separated. So this is the Cortex that if you plan to use Cortex to store metrics for long-term retention or make it horizontally scalable, you use Cortex. And Cortex has a complex architecture of having multiple distributors, ingesters, cache, and different, and writing to Cassandra again. It's a difficult system to manage. And again, from the Kafka, the Jaeger, that the distributed tracing pipeline we were talking of, it used to ingest data into Cassandra. And from Cassandra, there were two independent query service again. One was built using Jaeger, and the other was the Cortex query. And we built a unified front end where we used to try to combine metrics and traces together, right? So for the metrics part, we used to send the query to Cortex query, and for the traces part, we used to send the query to Jaeger query. But it was okay. So eventually the front end became equation, but the backend was actually very difficult to manage or handle at a huge scale. And so that's when we decided to have a simpler solution with a much elegant, in a much elegant way to handle these amount of data, and to open up further scopes for adding more features. Right. So that's why we started building SigNoz. I myself tried to combine those open source tools with Prometheus and Jaeger, and it is actually very difficult to bring up application metrics in Prometheus also. Like if for Prometheus, you have to bring up run multiple node exporters, and many of the node exporters do not give you deeper application metrics. I'll show you in the SigNoz demo what I mean by deep application metrics. Right, so you need to have much more information about the application rather than just the average duration of the endpoint or the application, and into different buckets like P90, P99, and P50. Right, so there are deeper insights that we can pull up from applications. And when I tried to set up application metrics using Prometheus and Jaeger and the complete setup to handle a huge amount of scale, it became very difficult. Right. So that's when we started building SigNoz. Like it should be, first of all, very much easy to set up. Right, there should be we based ourselves out of OpenTelemetry. Like we completely support OpenTelemetry, and if any organization is today decides to use OpenTelemetry, there is no single open source backend that is a complete solution for data coming from OpenTelemetry. OpenTelemetry today have started working on logging solutions also, like metrics, traces, and logs. All three today are combined into OpenTelemetry, but none of the backend solution is completely integrated. All three are separate. Let me talk to you more about what is OpenTelemetry. OpenTelemetry is a vendor-neutral initiative taken by CNCF Foundation also. It's another umbrella branch, and it takes care of uh, abstracting the instrumentation part or writing the code part of telemetry from the applications into those libraries. Like if you have a Python application or Flask application, you need to pip install a package to start sending data to any of these backends or Datadog, right? So for example, for a Datadog customer in Python application, you will install pip something Datadog library, and it will start sending data to Datadog agent, and it will start sending data to the Datadog cloud services, right? The same counterpart has been brought by OpenTelemetry, and OpenTelemetry has made the instrumentation vendor neutral. It means anyone can if a customer is switching from Datadog to New Relic, he does not need to change the code that where he has already written a lot of things about how to export business specific telemetry data. They don't need to change that. A customer has to use OpenTelemetry just once, and different vendors and tools supporting these matrices and traces and logs will be supported by this by integrating to OpenTelemetry. So you need to define exporters to those vendors, right? So it bridges out the layer, and hence it is very much efficient in terms of vendor lock-in. So apart from that, we did some sort of cost benchmark about how SigNoz is performing in storing the trace data and stuff as compared to Datadog. So we compared the pricing in a blog. You can visit here, and we found out it was very much easily 10 times cheaper than Datadog. Right. Apart from that, there is already an edge that you are able to control the data that you're sending to the backend, right? So the backend is hosted inside your infrastructure, so you can have a complete data governance policy, and you will not be audited by your lawyers about which kind of data you're sending to cloud and which are not. Right, so that's the virtue of open source. Apart from that, you can extend the open source code. You can completely see each and every file of open source that what is happening out there, and you can build more on top of that. Right, so that's where we started working on it. Now we'll move to the architecture of SigNoz. So this is how we plan things to work out. Like these are the applications 1, 2, and 3, similar to earlier. They will start sending data to OpenTelemetry collector. We have a Kafka in between, and we do stream processing using a Golang library. We write from OpenTelemetry collector to a topic in Kafka called OTLP spans. The stream processing reads from topic, writes to another topic, and Druid is a real-time ingestion or OLAP. Data store OLAP is basically analytical. It has analytical capabilities, like it can run aggregates on high-dimensional data, and is a columnar database. Right? So it is very efficient for data that is not changing, or we don't need to do upsert or delete operations. Right? So Druid is very much scalable and efficient in those terms, and we ingest data from real time from the Kafka topic to Druid, and we have a Golang service that queries data from Druid and exposes an API that the React JS frontend, our UI, can understand and display on your browser. On the back, the Druid writes the data into cold storage to S3. So we are using S3 as the cold storage, and Druid's disk storage as the hot storage. So by default, we have a 3-day retention policy in Druid, and the rest of the data we send to S3. That is very easily configured from the Druid APIs. So these are basically the components that SigNoz has. So this is an OpenTelemetry collector. We have an OpenTelemetry collector, Kafka stream processors, Apache Druid, query service, and frontend. Right? So now we'll like to look into a demo and see how things actually turn out to be. So I will show you.
Yeah, I mean,
Yeah.
so let me just quickly, recap some of the things that Ankit has discussed. So it's been super useful introduction, first of all, to observability and what exactly it means. What are the three pillars: metrics, tracing, and logs, and where each of the tools fits. Like for the metrics, you have Prometheus that scrapes metrics, and for tracing, you have Jaeger that has come up in the past few years under the CNCF ecosystem. And for the logs, you have your Elastic, and obviously you have now Loki, which is Grafana integrated, and Loki is for your structured logs with the labels. So all three these pillars have been discussed very beautifully by Ankit: the metrics, tracing, traces, and logging. And it is very true when you try to set up a monitoring solution, a complete observability solution for your infrastructure and the application. So you tend to obviously choose the open source tools, or you will be using Prometheus, you will be using Jaeger, you will be using Loki, Grafana. So all four you will be using, and then obviously if you want to scale that, you will be using Cortex or Thanos, so that you can scale the Prometheus to a HA kind of solution, because that doesn't provide you a HA solution out of the box. So the architecture that Ankit showed, with the open source things that you try to combine and have it as a scalable solution. You have your Kafka in place, then you have multiple different components, open source components in place that you are trying to mix and match, and then you deploy a complete observable solution. Now this, again, if you are a very small team, it becomes very difficult to do all these things. Now this is coming on top of your application development and application deployment. So this is apart from that, you are spending this particular amount of time in doing all these, consolidating all these open source tools and trying to build a solution. That it is possible, definitely, and but it requires a knowledge, it requires some effort, and it requires maintainable effort as well. So it requires all these things, and obviously as and when you scale, you face problems and you try to debug those. Now where SigNoz now that's where SigNoz now come into place, where they have tried to do something with the knowledge of all these problems that are there, and provide a complete platform which is very easy to install, easily scalable, and you can directly trace out metrics. And a very good mention of open telemetry over there, because that is something which is getting picking up pace, because everybody tends to now support open telemetry. So that is a very good aspect that SigNoz has already thought of it, and they're already in line with the open telemetry solution. So I think that's pretty neat. And yeah, so that's the whole kind of a short summary that Ankit has just discussed. So I think most of the questions that people have asked are already answered, about what is observability, in which language SigNoz is there. I think it is already mentioned by Ankit Anand that SigNoz is built mostly on TypeScript and Go, and the architecture is already shown. So yeah, super excited for the demo.
Cool. So one more thing, which languages does SigNoz support is basically everything that can be done by OpenTelemetry. So the instrumentation part, we are relying completely into OpenTelemetry, and the backend of those data that can be collected, that SigNoz is actually collecting, ingesting into databases and analyzing and storing. So we do all those parts, and the backend is basically agnostic of the languages that you choose to instrument. So the only condition is that OpenTelemetry must be supporting it, and we are writing on that.
Awesome.
Cool.
Can you increase the font size of the screen so that it's more visible?
I cannot. So it's a demo. I cannot increase the font. So I can zoom in and out.
Yeah, zoom in. Yeah, that works. That works.
Cool. So let me give you an overview. So like this is the landing dashboard where you get to view the list of all the services that we have. So the and we have P99 latencies, error rate, and RPS, or request per second, of those applications. On the left hand side, we have some tabs like metric, traces, service map, and what is the usage explorer, how much traces are we sending, how to add more instrumentation, like the languages that we are talking about, and the settings like if later, of course. So like today we can set retention policies here. Later on we will have team data kind of thing, and and the relevant role and RBAC policies there, right? So the sample application that you have seen is the same as the Uber guys or the Jaeger has given you. It is the hot rod application. So it's a ride on demand application. So whenever you click on a few buttons, so a cab will be called, uh, and it goes through four services, 5 microservices, and one of the services gets the data from MySQL. Another is pulling for driver information from the Redis source, and similar architecture mixes there to get a cab to you. So the UI of Uber seems pretty much simple to you, but the backend actually isn't. The request goes through multiple services and hops to get what you need, like a driver to your location exactly, right? So the front end service is one of those. Customer service, driver service, and route service are one of those. We can see the errors, like how much error are this showing us in our app, and how much request per second are we throwing it out. Like we know the route service is receiving roughly 10 times the number of requests that the other services are receiving. So when we click on front end, we uh, get this data. Like these are the charts which basically gives you the P99, P95, and P50th percentile latency profiles. Like these latency profiles are standard and are very much useful. Like P99 tells you how the 99% of your customers or the users of this service feel the latency to be, right? So it is very important. The average duration of services or the applications is very much little used today nowadays. So people focus more on more that, like the 95% of users, is their experience about the application and all. So we show the P90, 99, 95, and P50th percentile latencies, the RPS of that application, the if the application is facing some errors, and what are the top endpoints in that application. Like there can be multiple endpoints here, but this application has one endpoint only. And if an application is slow, like the P99 latency is high, you can see whether any specific API is responsible for that, right? So the number of calls, how many calls are you. So there might be cases where but it is not usually called in the last 30 minutes. It has just been called once, so it will be of low priority to you, right? So you can sort these data by the number of calls and the P95, 99 latencies, and you can drill deeper into it, right? So we for the same application front end, we have external calls data. Like this application might be calling other downstream services to get data and send it back to the upstream services. Like we display that data. This is the overall error percentage that we are showing it to them. Like what is the error of the different APIs that it is calling, what is the overall average duration. So this is the average duration of the APIs that it is calling. So this is the RPS of all the external addresses that it is calling. So this front-end service is calling other services which are at 0.0.0.0.0 at port 8081, and other one at port 8083. So these are the two services or the addresses that this application is calling, and the number of calls or the RPS that it is receiving. We can see roughly the 8083 service is 10 times more called than the service running at port 8081. So I will say this is in the background related to those route service and the customer service that we were talking about. The front end service calls the route service and the customer service, and the route service is receiving much more calls. So we are seeing that data. And this is the external call duration, or grouped by or layered by different endpoints. Like what is the time taken by 8083 port service at 8083 port and 8081 port. Like the service at 8081 or the customer service is giving you 378 milliseconds, and the service as 8083 is taking 51 milliseconds. Apart from that, if the service is making any database calls, then it will be visible here. Like if it is using MySQL or Mongo or any of the databases, you will be able to see the RPS here that how many calls to the database it is making, and what is the average duration of those calls. Like you would be able to figure out if it is calling MySQL, how much slow it is, right? So here this front-end service does not call any databases, so it is not visible here, right? So apart from that, if we want to drill down anything specifically, like here we see a spike. We can go to chart of 1 hour, and we can see the data here. We see there is a spike in this point, right? So we are getting a P99 latency of 1562 milliseconds. So now we want to have a look what is actually going beyond that time, how the traces look. So this is what we call mixing metrics to traces. When I click on this endpoint, I have an option to go to traces during that time period and that service. So we came to the traces tab, and this service name is already selected. That is the front-end service, and the time period has been already been chosen from that spike duration, right? So we get a list of all the spans or the events that were emitted during that period. Okay? So we saw there we were taking around 1800 milliseconds for that. So let's put a filter here, like we want to see all the events that are taking time more than 1500 milliseconds and less than 5 seconds. So when we apply that, we got one endpoint, right? So this is the event that is taking that much amount of time, and we want to look at the trace. This is a complete trace that is slow. Now this trace gives you a hell lot of details about the request. So this is the complete request. This request started. The left hand side of this is the service name. The right hand side is the name of the event or the operation name, as we call it in telemetry world. So this in total, this request has 51 events, list of 50 or 51 roughly events. The front-end service calls is getting called by /dispatch endpoint. The front-end service calls the downstream driver service. The front-end service calls its own endpoint /customer service. This service /customer service calls the customer service and the /customer endpoint, which gave a response code of 200, and the URL you can see here. The get is the method of the request is get, and it is calling the MySQL query at the last in this phase, right? So you can see the exact query where it was being fired. So I guess some of this will be masked in the ideal environment. So we can see the MySQL query statement was taking 1.17 milliseconds, like 1.1 seconds in the complete time, right? We can reset to the zoom, and the complete time taking around 1.5 seconds, and MySQL was taking 1.1 second. Then you might want to drill more into that specific query, what was going wrong. Apart from that, you can see the complete architecture of the events that are being thrown. So you can see these events are thrown in parallel, like these requests are sequential and these requests are parallel. So the driver service is calling a lot of Redis services, is calling Redis back by back, and again, till the point it gets some data, right? So this is the driver ID that is returned by Redis, and you get to see that the driver service is calling the Redis service and all, right? So again, the front-end service is calling the route service. So this is the route URL that is being called by the front-end service. So as I said earlier, that front-end service calls the route service and the customer service and the driver service also, right? So let me check how the service map looks here. So the service maps gives you an idea of the overall system, how it is performing, right? So these are the list of services that we have and the data points that they're sending. So the front-end service is getting data from driver service, customer service, and route service. And when you hover over a particular node or the service, you can see the P99 latency, the RPS, and the error rate that is throwing up. So the color of the service shows you the health of the service. If the service is sending 2x's or 3x's, it will be of green color. If the service is throwing 4x's, it will be of yellow color, and if the service is throwing 5x's, it will be the red color. So if there is no error percentage in the services, it will be of green color or yellow color. So this we can see we are hitting 9 requests per second to this route service. The front-end services has this latency, and the error rate is 0, and the request is 0.95 seconds. The size of the node denotes the the request, the number of requests that it is serving, and so is the speed of that, how much data that it is moving fast, how fast the data is moving actually. So this gives you an overview of how the services are interacting with each other and whether any of them in the red or yellow zone. Right? So you would like to drill down into those services first. So the usage explorer gives you an idea like how much events data are you sending to the SigNoz backend. Like by week, or we can switch by daily, hourly, and we can see the data of last week or first day, which kind of data you want to see. And so this is the total number of events or spans that SigNoz backend has received with the time range that we have provided. If you want to filter a specific service, you can see most of the event data is being generated by the front-end service. And similar is the case in settings today. You would be able to set the retention period of the data that you want to keep into Druid. For the hot storage, I would say, and for the cold storage, S3 is a much cheaper and efficient cold storage environment that you would like to save your data, and we support that. Right. So that is a brief overview of what things SigNoz gives today. I would like to show you how we can use S3 with SigNoz today. So you need to go to the configuration of the data, and for we have two types of setups that is provided. One is the Docker Compose setup, and another is the Helm chart setup for Kubernetes. So you need to add the S3 data credentials in this folder inside SigNoz, and you need to run the install.sh command. And for the same with the Helm chart data, so these are the data that is needed to run Druid properly. So the storage type, bucket name, and access key ID, region, and everything, right? So let me go back, and once you have a feel of how SigNoz, what kind of things that you would be able to see in SigNoz, let me show you what are the steps needed to achieve that, right? So these are the list of all the steps that you would be needing to achieve that state for your application, right? Like you need to install SigNoz first of all into a machine, I would say. So the current setup takes around 4 to 5 GB of RAM. So it installs SigNoz, Kafka, Druid, and all the other components. It is highly scalable, and I have tested it out to ingest roughly around 5,000 events per second in memory usage around 16 to 20 GB of RAM and 2 CPUs. So that is an architecture that is hugely scalable. But for small teams who do not need to have the complexity of Kafka and Apache Druids in place, we will be having a very simple architecture that installs ClickHouse. It will just install OpenTelemetry collector that receives data from the applications. It will send data to ClickHouse, and then we'll have the query service and the front-end service. That's all. So this will be running within 1 GB of RAM, and it will be very much handy for small teams who want to get started with SigNoz. Right? So that is almost done. The PRs are merged. Probably in a day or two, we will see a release so that people can install SigNoz with an option of using ClickHouse as a database, and it would be very much cheap in terms of resources. Getting back from there, all we need to do today to install SigNoz is clone the GitHub repository, go to this /deploy folder, and run this install.sh script. That's all. It will install, it will check whether Docker is there or not, Docker Compose is not there or not. It will install those in your environment. It will install OpenTelemetry collector backend components like Kafka, Druid, and the query service, the front end and UI. Everything it will install, and the UI will be accessible to you at port number 30,000. Right. So localhost 3000 is the port number where the UI will be visible. Now, once you have the SigNoz backend ready that can ingest the data and collect, analyze, and show it to the UI, you need to start sending data. So who will send data? The data will be sent from your application only. So let's take an example of a Java application. The command that you usually run to run your Java applications is Java -jar myapp.jar. So that is a usual command that you run to run your Java application. What we need to do is we need to download an OpenTelemetry Java instrumentation library. So this library is taken care of by OpenTelemetry organization, and we just use that. You just download a jar file. So, and once you have downloaded a jar file, you need to provide two environment variables. Like this is the environment variable hotel exporter OTLP endpoint. This is the IP of the SigNoz backend where we have installed this one. So if you're installing it in EC2, there will be an EC2 endpoint. And this port number varies for different applications, like Java has this one for 55680, Python has 4317, and different supports by OpenTelemetry. So you just need to specify this endpoint of SigNoz, your name of the service, like hotel resource attributes, name of the application that you wish to see in SigNoz dashboard. The path of -Java agent is the path of the library that you have downloaded, and just your run command of your Java application -jar and this. So this instruments your application and starts sending data to SigNoz backend. That's all you need to do. You can add more of your custom events and spams by using the OpenTelemetry SDKs, and they have provisions for doing so. You can add your own data, like customer type is equal to something, something, and something. Right? Post it, I would like to discuss how SigNoz is different from Prometheus, Jaeger, the other open source tools, and the commercial tools like Datadog. So from Datadog, it is clear, like we are open source products. You can run into your own infrastructure. You just need to pay the bill of your resources that you are using, like memory, CPU, and a disk storage, or S3 if you are using it. As compared to Prometheus and Jaeger, becomes very much difficult to run together when you use for long-term storage and scalability. Like Prometheus plus Cortex plus Jaeger, the architecture I showed you earlier is very difficult, and the data still remains in the single silos. We cannot mix the data to give you a better experience. The second is the UI of these tools is very much limited to the functionalities that they are handling individually. And Grafana is a tool that was made to display the time series panels and not built for observability, right? So these are not native UIs. So in future, we will have multiple different features like service map, SLOs. We'll have workflows specific to different use cases. Like if you have deployed something today, like usually every bi-weekly sprints, people in a companies deploy things, right? And in places where we have CI/CD, we deploy multiple times in a day. Right, so those kind of change detection or the deployment monitoring kind of things would be will be there. Like you want to see whether the things that you have deployed now in the last 30 minutes, how's it performing as compared to your past deployment. So these custom UIs are not possible today in Grafana. Right, going forward, we want to give you the abilities to have very powerful trace alerts on traces. Also today we have powerful error alerts on Prometheus. We can group, we can silence, we can give them a query. So like basically Prometheus gives you the capability to write alerts as code, right? You give the PromQL expression and it will evaluate the rules in a timely manner, and you can basically version control it, and it's very powerful basically for Prometheus. But the same analogy is missing completely for the distributed tracing data in Jaeger. They don't have any facility to set alerts. So we will be forking probably the alert manager of Prometheus and running capabilities to run Druid queries or ClickHouse queries on top of them, so that alerts can be run on tracing data also. In our roadmap, we plan to have AI/ML based support, AI/ML based features like autonomous anomaly detection and correlation between the different events and metrics, so that it can give you smart suggestions and all. Right, so these things will be there in the future. And Prometheus and Jaeger, as we told, it is very difficult to set up. Needs 30-45 days to set it up for an enterprise scale. We plan to be like Datadog for open source tools. Like it has to be out of box, like minimum setup needed, everything taken care of with plan of multi-tenancy, RBAC policies, and everything. Right. So these are the upcoming features that we have planned. Like first of all would be the custom metrics. So custom metrics specifically is very much costly in Datadog. Like if you have any business specific metrics that you want to track in Datadog, it will be very costly. And Prometheus, it is fantastic, but again, the pains of setting up Prometheus. So we plan to have custom metrics going forward very soon, and alerts on these metrics and traces. Then we'll plan to have logs also in Druid and ClickHouse. So it gives you the fundamentally the single integration tool for your complete observability with metrics, traces, and logs. We'll have tail-based sampling to control the amount of data that you can send to our backend. We'll have anomaly detection tools. We'll have workflows for different kind of use cases, common scenarios that people generally fall into to debug issues. Again, something like deployment monitoring or like how are the service workers performing, workers in the salary workers performing and all, right? So we are in a very interesting phase where we are looking for more and more support from the community, the people that, but the thing that we are building will be helpful to people, and they can support us back by coming to our repos, raising issues like it needs to be compatible to a lot of things, a lot of integrations. It has to be working in different kind of system, Kubernetes, K3s, Helm, Docker Compose and all. So what are the, so you can raise simple issues like this is a bug, this is not working, the UI is not proper, this kind of feature is needed. So these kind of efforts from the community will help us speed up in our journey to attain that state of single integration tool for observability that is open source. Like we try to achieve that. You can get involved with us by starting our repo, watching our repo, or raising issues like bugs, features, and performance issues. We have a Slack channel where workspace where we talk to the contributors, and we get a lot of help from them. Like these kind of issues are coming, a few issues can be taken up by those contributors. It helps in getting things done fast. You can also contribute by creating an issue if you're facing something, even if the slightest, smallest issues, right? So we have open sourced a few good first issues in our repository. So our languages that we work in are primarily React.js, TypeScript, and Go. React.js and TypeScript for frontend, and Golang for backend. So when you go to our repo and filter the issues with good first issues, you should be able to see a list of few issues that we have already out there, and few people are working on them also, but we would like more and more contributors to come join us in our journey. So these issues are very simple that will be helpful to solve these things out. Like our page URL direction is wrong. Maximum value filter has to be there in the latency. So little help from you all can make the product very much ready to be used by companies, and will help a lot in gaining the open source adoption. Right. So coming back to our point again, why we want to do self-host today in this 21st century. Like we all know, there is a huge flexibility of configurations that we love to control. Like we want to have the knobs of the tools that we deploy in our infrastructure, that first of all the source code is completely visible. We can build our own modules on top of existing features. Like you can just fork our repo and you can build more features on top of them, and you can contribute back to the community by raising a PR. You just need to pay for your the resources that you need to run SigNoz, like compute resources and storages. No SaaS, no marketing, no other kind of finance you will have to pursue around there. Again, from the security and compliance point of view, it is hugely beneficial to have the data, or specifically the tracing logging data, under your control for better data governance and for coming regulations like GDPR and CCPA and all. Apart from that, we have told you, like, we are built on top of OpenTelemetry. OpenTelemetry is the data creation platform for us, and we are the data ingestion platform, right? So OpenTelemetry removes any sort of vendor locking, and we agree with that philosophy, and we'll be working towards that. Thank you for being a wonderful virtual audience. I am looking forward to connect to you all with over LinkedIn, Twitter, or over email, and looking forward to have you all on a GitHub repo. Thank you.
Yeah, I think that was a very great presentation, including the demo. So we have seen a lot of features that SigNoz can do. So easy to set up on a regular compute instance on any of the cloud vendors, and you can just have a decent amount of memory and CPU size. Install SigNoz, and then use the OpenTelemetry for the instrumentation for sending the data. And we also talked about the comparisons with the open source solutions and with the Datadog as well. Obviously, Datadog is paid, so there is the major difference come there then and there itself. And with Prometheus and Jaeger, it's obviously open source tools. You take the ownership of setting those up, connecting the dots, and be responsible for the scaling. Whereas in SigNoz, everything is there and out of the box solution. I think it's very ambitious roadmap. Roadmap looks very good to me with all the features that are coming up or are listed in the roadmap. That would definitely make a strong impact in the observability space as an open source complete solution. And yeah, I think I will definitely try out SigNoz, and if any of you try out SigNoz, just tag them on Twitter or LinkedIn and let them know like how you plan to use it, what all features are missing. See, uh, they have started something which has great potential, and you have seen the roadmap, so already there is potential. So now you can just try it out and install on VMs and map the application, send the data, analyze it, see what all things are missing, see what all dashboard customizations you require, see what all alerting customizations you require, see what all tracing customizations you require, raise the issues. You can yourself work on the issues, and Ankit and team would definitely be happy to guide you through the process if you are willing to do the code contributions to Golang, React, and their front end and the back end. So I think those things will accelerate the journey. Obviously they'll be moving towards their roadmap, that is for sure. They
Right.
have a team who's working, but the community always accelerates the journey. So
Exactly.
that's where we have to come in and try it out because it has potential. And if you write any blogs, to definitely tag out Ankit on Twitter and let him know like you have done something as a community contribution, because every contribution matters. And the docs, the code, even the usage, even the blogs, everything would matter. And
Right.
let them know what pieces are missing, because I feel the roadmap is pretty decent. And if you people let him know like what things are missing, probably it would be a very good solution for especially when you are starting up, for the startups or mid-size, even for the enterprises. But for the definitely for the startups and the mid-size organizations, it'll prove to be a very first choice kind of when it comes to observability in the application. So that's their goal, and I think we as community can definitely help and support that. So at KCD Bangalore, which is happening on 25th and 26th of June, there is a SigNoz workshop where there'll be more deep dive session, and where there'll be like more hands-on kind of where you will be able to spin up SigNoz, see how you will actually connect the dots, actually connect the
Right.
application. So that's a complete workshop. Obviously, it's 1 hour session. We cannot include everything, but that is
Mhm.
a complete set workshop, and a lot of things will be included there. So make sure you check out KCD Bangalore, which is happening on 25th and 26th of June. And if you are new to the channel, please make sure you subscribe that, and stay tuned for the upcoming stream. The next one is on 4th of June on Talos, which is a very good native Kubernetes operating system. And we'll be talking more about Talos, a modern operating system for Kubernetes. Super interesting project it is, and I'm really excited for that as well. So KCD is basically Kubernetes Community Day. So you can go to kcd.blr, kcdblr.com, and it will redirect you to do all the workshops that are happening. You can select any of the workshops that you get kcdblr.com. And yeah, that's pretty much it from my side. And thank you, Ankit, for the amazing session that you did today on SigNoz. Very interesting and promising roadmap. And thank you to the audience who has joined today. Feel free to share it with other folks. And anything you would like to just add, Ankit?
Sure, man. So I love the few points that you pointed out, like community accelerates the work that we do in open source. Like, so that's the prime purpose that we open source, that we get feedback fast. Like, so if so we are open to all sorts of criticism and the things that we are not working right now. I understand things might be buggy or we may be missing a lot of features. We are trying to do all of them and fix all of them very fast. So don't hesitate in pointing out things that are missing or things that are not working perfectly. If you remain silent, it will slow down the speed of the project. Like so please speak up, come to us in GitHub issues or in Slack. Just let us know, tag anywhere else in LinkedIn and Twitter, and we should be going with that. Thank you, Sayam, for the wonderful opportunity. I love talking to you.
Yeah, same here. It was a great presentation, full packed agenda. I loved that. So it covered all the things that we had on the agenda, and I hope everyone who is watching now and who will be watching later will definitely enjoy what SigNoz is trying to bring, and with the open telemetry instrumentation already in place. So these are the things when we think of a product at a mature level. So definitely, I think it will get a lot of attraction, and the roadmaps looked solid to me. So I hope you get some of the community contributions from the stream as well. So I definitely will check out the repository and give you my opinion on that and where things can improve and all those things. You will see me around. So thank you so much for joining, everyone, and thank you so much for being on the stream, Ankit. See you in the next stream, everyone. So take care. Goodbye.
Bye bye. Take care.